All right, guys, so let's start, okay? And a couple of things, okay, before the start of the lecture, okay? And the first is on Monday, okay, so I didn't receive the email, okay? I didn't check my email until like maybe after the lecture, okay? So that's it. I have the lecture on Monday, okay? So if you missed the lecture on Monday, I'm sorry about that, okay? So you can look at the video, okay? So the recorded video, okay? And pretty much we just did some practice and those go through kind of quiz 3, okay? So quiz 6, okay? And just start kind of chapter 16, okay? So not too much new material. Right, and then more important kind of the exam 3, okay? So exam 3 will be on Friday, okay? So 8 to 10 p.m. Okay, so give you 2 hours. Okay, so suppose you should able to finish in the 1 hour. Okay, but give you some extra time. You can download, scan your work and those the upload online. Okay. And so if you have a conflict schedule, okay, so some students kind of have to work at the evening shift, whatever, okay. You can let me know, okay. So I can arrange some kind of makeup exam for you, okay. Yeah. And make sure that during the exam, okay, bring your IR chart, okay. NMR chart, okay. So the both carbon NMR and those proton NMR kind of the chart, okay. And also bring a calculator, okay. Yeah, for the exam, okay, because we have some kind of rule 13 calculation questions, okay. And also keep in mind, okay, so the homework, okay, so will be due on same day, okay, on Friday, okay. So both online homework and also the actual credit homework, okay. So online homework, both at kind of 11:59, okay. So at the Friday night, okay. So make sure you hand in homework on time, okay. And so I will post some kind of practice exam probably this afternoon, okay. Yeah, practice exam, okay. So please work on it, okay. And it has very similar question as the real exam, okay. And another important thing about kind of exams, I will post the question sheet, okay, and also answer sheet, okay, both online, okay. And so make sure that this Friday, okay, this Friday, okay, this Friday, okay, exam 3, okay. Yeah, so exam 3 only cover chapter the 13, 14, and then 15, okay, note 16, okay, 16, the probably won't get finished yet before the Friday, okay. Yeah, only 3 chapters, okay, 13, 14, 15, okay, so and so quiz 7, okay, so last quiz, okay, so you cover kind of chapter 16, okay. And so I post kind of question sheet and also the answer sheet online, okay. So you only need kind of print out your the question answer sheet, okay. So fill your answer there and then upload it online, okay. So the question sheet kind of but if you like print out your question sheet, okay, so practice on it, okay, you kind of draw some kind of structure on it, that's fine, okay. But if you don't want to practice, just look at kind of on your screen and then answer all the questions on the kind of answer sheet, okay. So that's just keep in mind, okay. So so answer sheet, you need to submit, okay. Yeah, so that's something to keep in mind, okay. So make sure you write your name, whatever on it, okay. Yeah, okay, so I recorded this video, okay, so if you have this lecture, okay, so if you have the technical issue, okay, so I'm going to kind of you can rewatch the video, okay. Right, so any question about the exam? Yeah, if you have a conflict schedule, you cannot take exam at 8 to 10 on Friday. Okay, so you can kind of email me. Okay, so I can give you kind of make up exam. Okay, pretty much I email you the exam. Okay, and then you send you back here your answer in 2 hours. Okay. Yeah, I will upload a practice exam probably this afternoon or this evening. Okay, yeah, and you guys can work on it. Okay. And also tomorrow discussion, I will do a lot of practice. Okay, so help you guys kind of know some types of question. Yeah, you'll see kind of in the exam. Okay, so you should have plenty enough time. Okay, so the exam kind of designed for only 1 hour. Okay, but you have 2 hours. Okay, so take your time. Okay, so no rush. Okay. And during the exam, I will open my the Zoom and also the monitor my email. Okay, so if you have kind of technical issue or other questions, okay, you can just open the Zoom kind of talk with me. Okay. Right, any other questions? All right, okay, so if there's no further questions, okay, so we continue the lecture, okay? All right, okay, so last time we just started kind of the aromatic chapter, okay? So we know that kind of the aromatic compound, okay, have very unique kind of chemical property and also physical properties, okay? And they also have kind of the very unique structures, okay? And and here's some kind of classification of the aromatic compound, okay? So arene, we know that kind of called aromatic the hydrocarbon, okay? All right. So example, for example, naphthalene, okay? So for this type of compound only has the carbon and hydrogen inside, okay? Yeah, naphthalene, okay? And the arene actually cannot include kind of benzene, okay? So that's the arene, and then benzene belongs kind of the arene, okay? Yeah, that's benzene, okay? And then the aromatic compound kind of much more broader kind of definition. Okay, so uh, include arene. Okay, yeah, aromatic compound. Okay, so aromatic compound kind of no necessarily kind of has only carbon and hydrogen, can have any kind of heat atom. Okay, and for example, kind of pyridine. Okay, yeah, so that's the belongs kind of aromatic compound, but doesn't belong to kind of arene. Okay, so that's something to keep in mind. Okay, and the aromatic compound kind of very huge kind of group of the compound. Okay, so kind of compares to kind of aliphatic compound. Aliphatic compound normally kind of the long carbon chain and also some kind of although they're kind of unsaturated kind of double bond, triple bond. Okay, but they have big difference kind of the properties from kind of aromatic compound. Okay. So all the ways, okay, all the ways kind of the classic kind of the aromatic compound based on kind of their special structures and chemical property, even kind of odor, okay. So aromatic compound normally have some kind of special odor, okay. So that's why they call it an aromatic compound, okay. But nowadays, kind of people use some kind of special rule, okay, to classify whether one compound is kind of aromatic compound or not aromatic compound, okay. So that's based on kind of the Hooker rules, okay, Hooker rules, okay. So that's come kind of fundamental of this chapter, okay. The Hooker rule, okay. So there are kind of the four criteria, okay, so for the Hooker rule, okay. So we go through kind of one by one, okay. And the first one kind of the so make sure kind of have to kind of satisfy all four criteria, okay, and then one compound can be kind of Hooker can be kind of aromatic compound. First one kind of this compound has to be kind of cyclic, okay. So example showed here, okay. So the benzene, okay, and compare with kind of 135 hexene triene, okay. And then benzene has kind of the fully conjugated, okay, so each carbon, okay, so has kind of the p orbital, empty kind of actually kind of the 2p orbital on it, okay, and then that's kind of overlap each other, okay, and then form kind of conjugation, okay. If kind of the not cyclic, okay, so the break up, okay, so like 135 kind of hexane triene, okay, although there's kind of the p orbital on all the kind of the carbons, okay, but the break up, okay, so the end kind of the two p orbital cannot overlap each other, okay, and then that's cannot form kind of the aromatic compound, okay. So that's the happy cyclic, okay, the first kind of criteria, okay. And then second one, okay, so the molecule has kind of planar, okay. So example showed here is so reason for that kind of you have to make sure that all the p orbital kind of overlap to each other, okay. So if it's not planar, okay, so that's there's a band, okay. So the p orbital cannot kind of overlap, and then the electron cannot delocalize, okay. For example showed kind of for the cyclooctatetraene, okay. So cyclic structure, okay, each atom has kind of each carbon has kind of p orbitals, okay, but the whole molecule actually kind of this the top shape, okay. So meant to be the kind of the pocket structures, okay. So in this case all all the kind of the p orbital not aligned, okay. So the kind of some kind of the angles, okay. So that's this p orbital cannot overlap with this p orbital or this one, okay. So that's the you cannot form conjugations, okay. So that's why kind of the cyclo octatetraene actually kind of the non-aromatic compound, okay, non-aromatic compound, okay. Yeah, if you guys have any question, okay, still can just can type in the chat window, okay. And it's kind of property more or less like the alkene, okay. So CC double one, okay. So remember alkene can do the kind of addition reactions, okay. So the cyclotetraene can also do the addition reactions, okay. Addition reactions kind of you add 2 electrons, okay, onto your CC double, okay, make this CC double kind of saturated, okay. So that's called kind of addition reaction, okay. And we already know that kind of for the benzene, okay, aromatic compound, you cannot do any kind of the addition reactions, okay. You can do substitution, replace hydrogen with some other atom, other groups, okay, but cannot do addition, okay. And so that's one big difference from kind of aromatic compound from kind of alkene, although all of them have kind of both have kind of the CC double, okay. So that's the criteria 2, okay, has to be planar, okay. Criteria 3 is the whole molecule has become fully conjugated, okay. So what's that mean, okay? So that means kind of all the atom, okay, in the ring, okay. I mean kind of for example the carbon in the kind of benzene, okay, all will have kind of the 2p orbitals, okay, 2p orbitals, okay. And in other words, okay, so all the atom on the ring, okay, has to be kind of sp2 hybridized or sp hybridized atoms, okay. Right, so that's keep in mind, okay. So the sp2 sp hybridized, okay. So if the atoms kind of the sp3 hybridized, okay, so that's you break up conjugation, okay, because there's kind of no 2p orbitals, okay, and then you cannot form kind of the fully conjugated kind of ring system, and then the electron pi electron cannot delocalize, okay. So that's the kind of important thing, kind of use some old knowledge we learned in kind of chapter maybe 3, okay, how to assign kind of hybridization, okay. So sp or sp2 or sp3, okay. So remember kind of we count the electron the density numbers, okay. So 4 electron density number, okay. So sp3, 2 electron density number, 3 electron density number, sp2, and then 2 electron density number, sp, okay. Right, and then the benzene kind of fully conjugated, okay, and then comparison kind of 1,3 cyclohexene, okay, hexene diene, okay. So this molecule kind of the cyclic and also planar, okay, but there are kind of 2 carbon, okay, sp3 hybridized, okay. There's kind of no p orbitals, okay. And then similar thing for kind of 135 cyclohexene triene, okay. So this one also cyclic and also planar, okay, but there's only 1 carbon is kind of the sp3 hybridized, okay. So this case, okay, so totally break up conjugation, okay. So there's kind of not fully conjugated, okay, and then the whole molecule as kind of the non-aromatic, okay. And be careful with some kind of situation, some kind of positive charge species or kind of negative charge species, okay. So although there's kind of no pi electron in this charge species. For example, this 135 cyclo heptatryene cation. Okay, so totally there are kind of 7 carbons. Okay, so fully conjugated and also the planar structures. Okay, and then there's kind of empty p orbitals. Okay, on this the positive charge carbon. Okay. So although there are kind of no pi electron in it, okay, but this one can fully conjugate with other kind of the pi bond system, okay, other kind of 2p, okay, and then this molecule actually also aromatic compound, okay. So that's something little bit keep in mind, okay. We'll talk about more kind of charged kind of aromatic compound later, okay. All right, So actually you can apply kind of the knowledge we learned before, okay. So this charged carbon sp2 hybridized, okay. So only 3 the electron density, okay. So CC bond, and then there's one CH bond, okay. So and sp2 hybridized, okay. So that's should be kind of the conjugated system, okay. Right. And then the last the criteria, okay. So also kind of actually most important kind of 4+2 pi e, okay. So for the compound, even you have kind of even have kind of the planar structure, okay, fully conjugated, and also kind of the ring structure, okay. So it's not necessarily can be aromatic compound, okay. And then you have to count how many kind of pi electron in this kind of the delocalized kind of pi system, okay. Only kind of the 2 pi electrons, okay. So that's the number of pi electron, okay. So 2, 6, 10, 14, and then 18, okay. So those number of pi electrons can be kind of aromatic compound, okay. And then last a lot of number to memorize, okay. So in this case, people develop kind of special formula, okay, help you memorize this kind of the pi electrons numbers, okay. So that's the kind of the 4n plus 2, okay. So what n means? N is kind of just the whole number, okay, integer, okay, okay. All right. So can be 0, 1, 2, 3, 4, 5, 6, 7, whatever, okay. So all right. So for example, okay, so if n equals to 0, okay, and then 4 times 0 plus 2, okay, so that's give you 2, okay. So that's here, okay, much kind of 2, okay. So if n equal to 1, okay, so 4 times 1 plus 2, okay, that's give kind of 6, okay, so 6, okay. And then if equals kind of 2, okay, and then 4 times 2 plus 2, okay, kind of 10 pi electrons, okay. And then you can go ahead kind of 3, 4, and go ahead, okay. And then so based on this formula, okay, so that's the easy figure out how many pi electrons, okay, can be right for kind of aromatic compound, okay. So 4 plus 2 just help you guys memorize how many pi electrons kind of need, okay, for the aromatic compound, okay. Just keep in mind, okay. So n has kind of integral, okay. So can be 0, okay. So and so for benzene, okay, so has kind of the 6 pi electrons, okay. So that's why the benzene kind of the aromatic compound, okay. So follow kind of the 4 plus 2 pi electron rule, okay. And so then come kind of some people ask kind of if not 4 pi electrons, okay. So other number of pi electrons, what kind of compound it will be, okay. So that's come kind of the 4 pi electrons, okay. 4 pi electrons, okay. So the example is kind of this the cyclobutadiene, okay. So this compound, okay, has only 4 pi electrons, okay. So cannot fit in kind of 4 plus 2 rule, okay. So but fitting kind of 4 pi electrons, okay. And then there are kind of special category for this type of compound, okay. We call kind of anti-aromatic compound, okay. Anti-aromatic compound, okay. So we talk about more kind of how do we classify kind of anti-aromatic compound, aromatic compound, and then so non-aromatic compound, okay. So that's something to keep in mind, okay. And they have kind of big difference in their kind of stabilities, okay. Right. Okay, so that's keep in mind, okay. So 4 criteria for Hooker rules, okay. So the restructure, okay, and then the fully conjugated, okay, and then 4n plus pi roots 4n plus kind of 4n plus 2 pi electrons, okay, and fully conjugated, okay. So yeah, that's here the keep in mind this full criteria, okay. So yeah, we will determine whether kind of one more kind of aromatic compound or not, okay. And also yeah, for the last one, okay, 4 plus pi plus 2 kind of pi is, okay, count kind of pi electrons, okay, not number of atoms, okay, or not kind of number of pi kind of p orbitals, okay, in a ring, okay. So that's here keep in mind only pi electrons, okay. All right, okay, and then now we can the kind of classification of the different compound, okay. So yeah, aromatic compound, okay. Right. So first, yeah, they have kind of the cyclic structure, okay, and then has kind of the planar, okay, also, okay. Okay, and also yeah, has to be kind of the fully conjugated, okay. And has kind of 4n plus 2 pi e, okay. So that's here we learn kind of the for the Hooker rule, okay. All right. So what's kind of anti-aromatic compound, okay? So anti-aromatic compound kind of the first 3 criteria actually exactly same as kind of aromatic compound, okay. Has to be cyclic, okay, planar, okay, and then fully conjugated, okay. But anti-aromatic compound has the 4n pi e, okay. So like the 4 8k pi electrons, okay. So that's the anti-aromatic compound, okay. All right, and then comes kind of your non-aromatic compound, okay. Okay. So non-aromatic compound, all other situations, okay. Right. So for example, okay, so yeah, if you have kind of 3 pi electrons, okay, we can call them non-aromatic compound, okay. If you not cyclic structure, okay, or not kind of the planar structure, or kind of not fully conjugated, okay. So that's what we all call them kind of the non-aromatic compound, okay. So yeah, that's something to keep in mind, okay. And then the more important thing is kind of the stability of these 3 guys actually kind of different, okay. So yeah, more stable is kind of aromatic compound, okay. So yeah, much more stable compared with kind of non-aromatic compound, okay. And then least stable one kind of the anti-aromatic compound, okay. Yeah. So that's kind of important thing for this chapter, okay. And also explain kind of why the molecule like to be kind of aromatic because kind of more stable, okay. An example can show you guys here, okay. So right. So benzene, okay. So right. So benzene kind of aromatic compound more stable kind of than 135 kind of the cyclo cyclo the hexene tetraene, okay. Actually no cyclo hexene tetraene, okay. So yeah, that's here, okay. So because this is kind of a non-aromatic compound, okay. And then the 1,3 kind of the 1,3 kind of butadiene, okay. More stable kind of than 1,3 kind of the cyclo the butadiene, okay. So reason for that kind of this is non-aromatic compound, this kind of anti-aromatic compound, okay. So that's the some kind of stability comparison, okay. All right, okay. So now we move back, okay. So for the aromatic compound, okay, there are kind of a huge group, okay. So aromatic compound, okay. So yeah, there's kind of a lot of the different structure and the different kind of the formation or whatever, okay. So now we will learn kind of the different types of aromatic compound, okay. So the first type is kind of aromatic compound, kind of we call it kind of aniline, okay. So aniline kind of just single ring with kind of alternating double bond and also single bond, okay. And this ring can be huge, okay. So yeah. Benzene actually kind of belongs kind of the aniline, but probably small, actually not small kind of aniline. And so as long as kind of the ring structure planar kind of fully conjugated and the full kind of 4 plus pi 2 4 plus 2 kind of pi electron, okay, and then that will be kind of aromatic compound, okay. Example showed here is kind of the 14 aniline K and also 18 aniline K, and for the 14 here is kind of indicate kind of the atom numbers, okay, in the ring K, and also pi electrons, okay. So 14 pi electrons kind of follow 4 plus 2 rules, okay. So that's why kind of aromatic. And same thing kind of for the 18 aniline K. So 18 is kind of total carbon numbers in the ring K, and also total number of pi electrons, okay. So that's all follow kind of 4 plus 2 rules, okay. So that's also aromatic compound, okay. And one thing you guys can keep in mind kind of the how to count pi electrons, okay. So each double bond, okay, you count as 2 pi electrons, okay. Each double bond kind of count, okay. So that's somehow kind of useful, okay. Later when you kind of figure out one molecule kind of follow 4 plus 2 rule or not, okay. So for example, okay, for the 14 the aniline, okay, so there are kind of totally 7 pi bond, okay. So 1, 2, 3, 4, 5, 6, 7 pi bond, okay. And each pi bond has 2 pi electrons, okay, and then totally 14 pi electrons, okay. Get n. So n is kind of the whole number, okay, whole number, okay. So okay, so we can do. Right, this way, okay. So for example, you have kind of 4 pi electrons, okay, and then you want to see whether you can fit into kind of these rules, okay. So you can do some little bit simple math, okay. So then kind of you kind of move kind of 2 here, okay. So that's kind of become 12, okay, and then 4, okay. So each side you minus 2, okay. All right, so that's here, okay. Right, and then you find kind of the n equals to kind of 3 in this case, okay, equal to 3, okay. So that means kind of that's whole number, okay. So that's the 14 pi e kind of the can be fitting kind of 1 plus 2, okay. So if you have kind of the freedom, okay, just kind of 8 pi electrons, okay. 8 pi electrons, okay, you try to see whether fitting kind of 4 plus 2 kind of the formula case, you can do same thing, okay. So the minus 2 both sides, okay. So that's 6 and then 4, okay. So in this case, okay, so n cannot be whole number, okay. So that means kind of 8 pi cannot be kind of the follow kind of 4 plus 2 rules, okay. So that's just kind of the help you memorize, okay, figure out how many pi electron right for kind of the kind of the 4 plus 2 pi e, okay. All right, okay. So continue, okay. And so there's one special case for the aniline is the 10 aniline, okay. So 10 aniline, 10 pi electrons, okay, follow kind of 4 plus 2 rule, okay. So n is kind of equals to 2, okay. But the whole molecule actually kind of not planar, okay. The reason for that kind of the ring side for the 10 aniline kind of too small, okay. So showed here, okay. So and then there kind of the 2 hydrogen, okay. So this hydrogen and this hydrogen, okay, point towards each other, okay, and then they're kind of strong, the electron, the stack hindrance, okay. So they're kind of string, okay. So in this case, for the 10 aniline actually kind of note the planar structure, okay. So little bit kind of the folded kind of packed structures, okay. So that's your real structure for the 10 aniline, okay. So in this case, the 10 aniline kind of not planar animal, okay. So if it's not planar, okay, cannot be aromatic compound, okay. So 10 aniline actually belongs kind of non-aromatic compound, okay. All right. So that's the first type of aromatic compound, okay. The second type of aromatic compound called kind of the polycyclic aromatic hydrocarbons, okay. So that's just kind of a bunch of benzene case, kind of the fused together, okay. So it's kind of the shared the pair of the pi electrons, okay. So pi bond, okay, and it goes together, okay. So example for example the naphthalene, okay. So and the naphthalene has totally 5 pi bonds, okay. So each pi bond 2 pi electrons, okay. Totally 10 pi electrons, okay. Another example kind of anthracene, okay, so yeah, 3 benzene ring kind of the fused together, okay. And last one kind of phenanthracene, okay, so yeah, 3 benzene ring kind of fused together, okay, so yeah, all of them kind of belong kind of the aromatic compound, okay. And actually for this type of kind of aromatic compound, quite stable, okay, very stable, okay, normally won't have kind of reactions, okay. Reason for that kind of they have kind of more resonance structures, okay. So for benzene case, we know that kind of draw 2 resonance structures, okay. But for the with the increased kind of the benzene number for this the polycyclic aromatic kind of hydrocarbon, okay, you can draw more resonance structures, okay. Example for kind of naphthalene, okay, naphthalene can draw 3 resonance structures, okay. So we learned the kind of resonance structure chapters, okay. So the more resonance structure, more stable, okay. So that's the why it's here, okay. And actually kind of there are kind of huge group of the polycyclic aromatic kind of the hydrocarbons, okay. So people call it kind of PAH, okay. So abbreviation, okay. So very kind of the popular in the kind of chemistry field, okay. So because they have very kind of unique property, okay. So especially kind of physical and chemical properties, okay. And so some example showed here, okay. So porphyrin, okay, fluorine kind of C60, okay. So the kind of people could call the spooky ball, okay, whatever, okay. And then another popular kind of pH is kind of carbon nanotube, okay. So that kind of a lot of benzene kind of fused together, build up some kind of this the tube structures, okay. Can be the monolayer or kind of the multi-layers, okay. And nowadays kind of most popular kind of the pH is kind of graphene, okay. The graphene kind of many huge number of the benzene kind of fused together, okay, with kind of only one single layer of the one molecule kind of layer of the molecule, okay. So kind of whole molecule, kind of whole thing kind of one molecule, but very kind of big size, okay. So they have very unique kind of chemical property and also physical property, okay. Very kind of the whole kind of research area, okay, in our chemistry the field, okay. So right, okay. So that's about kind of the aromatic compound contain only carbon and hydrogens, okay. Like I said before, okay. So the actual kind of heteroatom, okay, containing the compound can also be aromatic compound, okay. So can contain kind of the oxygen and nitrogen, also sulfur, okay. So that can also be aromatic compound, okay. And the tricky thing come here is kind of how do you count the pi electrons, okay? Because for this type of aromatic compound, okay, also has kind of the lone pair electrons, okay. So on the kind of heteroatom, okay. So oxygen, nitrogen, and the sulfurs, okay. And then sometimes kind of you need to determine kind of whether lone pair electrons are kind of the part of the pi bond delocalized pi bond system or kind of just by its own, okay. So that's the important kind of determine whether this molecule follow kind of form plus pi is, okay. Okay, so that's here's something I want you guys kind of record, okay, write it down kind of exactly what I'm kind of right here, okay. All right. So to determine whether lone pair electrons, okay, on the heteroatom belong kind of delocalized kind of the pi bond system or not, okay. So you need to kind of what's bonding, okay, on the heteroatom. So if heteroatom, okay, are connect only by kind of connected by kind of the double bond, okay. Or for example, kind of the CO double bond, CN double bond, okay, or CS double bond, okay, and then don't count kind of the lone pair electrons, okay. So don't count lone pair reactions on heteroatom, okay. And if we have heteroatom, okay, connect by only the single bond, okay? Then count only one pair of the lone pair electrons, okay? Yeah. So write it down, okay? So that's kind of some kind of important thing, okay? So for example, kind of the oxygen normally has the two lone pair electrons, okay? And when you connect by only one two single bond, okay? So count only one pair, okay? Count only one pair, okay? Right. And the example showed here, okay? So that's the pyridine, okay? So pyridine, okay, so there's kind of one lone pair electron on the nitrogen, okay? So whether this lone pair electron belongs kind of this pi bond system or kind of we don't count it, okay? So as kind of the 2 pi 4 plus 2 pi is, okay? So that's you kind of what's bonding for this nitrogen, okay? So there's kind of already double bond, okay, bound to kind of this nitrogen, okay? So in this case the don't count this the electrons on the nitrogens, okay? That's don't belong kind of this delocalized kind of pi e system, okay? So you only count kind of the pi electrons, okay, on this double bond, okay? So that's 6 pi electrons, okay, for kind of 4 plus 2 pi e, okay? And for the reality, okay, so what structure looks like here for the pyridines kind of something like this, okay? So each of the pi system, okay, so under the pyridine, okay, there's kind of one electron inside, okay. So that's why kind of totally 6 pi electrons, okay. Each has kind of one electrons, okay. And then for this nitrogen case, so that's kind of the sp2 orbitals, okay. So so totally 3 sp2 orbitals, okay. So and then one the pi orbitals, okay, a p orbital, okay. Hold this lone pair electrons, okay. So this lone pair electron not involve kind of conjugation of the kind of the pyridines, okay. So that's why kind of don't count these two, okay. So that's why explain kind of the pyridine normally has the relative strong kind of base status, okay, because the some protons, okay, come in, okay. So combine the lone pair electron on nitrogens, okay, and then that's kind of the increase kind of that's why kind of pyridine has kind of the strong base status, okay, because this lone pair electron available bind kind of the protons, okay. And the comparison kind of the pyro, okay. So pyro has kind of the also has kind of the ring structure conjugated system, okay, and then but nitrogen, okay, has the only single bond to it, okay. So let's come here, okay. So here it has connect only by single bond, okay. So in this case, when you count the pi electrons, okay, so you need to count the lone pair electrons on the nitrogens, okay. So 2 4, okay. So 4 pi electron from the theta bond, okay, and then another 2, okay, come from lone pair electron of nitrogens, okay. So that's totally 6 pi electrons follow n plus 2 rule, okay. So that should be kind of aromatic compound, okay. So that's also here, okay. So pyro has kind of p orbitals, okay, on every kind of conjugated atom, so it's kind of fully conjugated, okay, and then totally kind of 6 pi electrons, okay, and then 4 from kind of pi bonds, okay, theta bond, okay, and 2 from kind of lone pair is, okay. So here's kind of the orbital of the pi orbitals of the pyridines, okay. So you see kind of no lone pair electron in kind of p orbitals, okay, in p orbitals, okay, and then that's involve kind of conjugation with kind of the other the p orbitals, okay. So that's why kind of pyro also kind of aromatic compound, okay. And also explain why the pyro kind of the pretty weak base status, okay, because the pyro lone pair electron in kind of the aromatic systems, okay, don't want bond with kind of the electrons, protons, okay. So if bond protons, okay, so then this nitrogen will become kind of sp3 hybridized, okay. Sp3 hybridized, okay, break up conjugation, okay, the molecule won't become aromatic, okay. Aromatic compound more stable than non-aromatic compound. Okay, so that's here the molecule won't be aromatic compound. Okay, so yeah, that's why don't want kind of bond with kind of protons. Okay, and compare with kind of pyridine. Okay, pyridine has kind of just nothing, no pi bond. Okay, pyridine kind of it is bond kind of the protons. Okay, so pyridine kind of the 10 to 14 times kind of stronger base than kind of pyro. Okay, although these two have very similar kind of the structures. Okay, but the pyro pretty much no base status. Okay, because they don't want to break up kind of aromaticity. Okay. And the example kind of here it's kind of for the furan. Okay. Furan has kind of the oxygen in the ring. Okay. And then this oxygen only connects by kind of single bond, single bond. Okay. So in this case here, when we count here the pi electrons, okay, in the kind of pi bond system, okay, only count one pairs. Okay, keep in mind. Okay, so yeah, okay. Count only one pairs. Okay, so although oxygen has kind of two lone pairs, kind of but only count one pairs. Okay, and then that's give kind of 6 pi electrons. Okay, so also aromatic compound. Okay. And so that's kind of the orbital arrangement for the kind of the furan. Okay, so yeah, you can see kind of the one lone pair electron in the kind of the p orbitals. Okay, another lone pair electron actually in kind of sp2 orbitals. Okay, so that's why count only one pairs. Okay, right. Give you guys kind of more example. Okay, so this time okay we have kind of more than the one heter atom in the molecule. Okay, so. All right. So for example, this molecule, okay, has kind of nitrogen, oxygen, okay, all three in one molecule, okay. And then how do you count kind of pi electrons, okay? So definitely kind of double bond, okay, so count 2, okay, and then each count 2, okay, so yeah, give kind of 2 to the 4, okay. And then for the nitrogen, okay, although it has kind of lone pair electron on it, okay, but yeah, it's connected by kind of the pi bond, okay, double bond, okay, so don't count kind of any lone pair electron on nitrogen, okay. But for the oxygen, okay, connect only by single bond. Okay, so in this case, the count one pair, so only one pair of the lone pair electrons on the oxygen. Okay, so that's for example, this pair. Okay, so that's 2, 2, 2. Okay, so 6 pi e. Okay, so this should be aromatic bond. Okay, all right, and then give you kind of another example. Okay, so that's the we call kind of the tetrazinc. Okay. Yeah, this one. Okay. Totally three nitrogen in the molecule. Okay, three the nitrogens. Okay, so two nitrogen connect already by kind of the pi bond. Okay, so that bond. Okay, so don't count lone pairs on kind of nitrogens. Okay, but for the bottom nitrogen, okay, connect only by single bond. Okay, so in this case you need to count kind of lone pair electrons on the nitrogens. Okay, on the bottom nitrogen. Okay, and then that's part of the pi bond system. Okay, so the corrugated pi bond system. Okay. So that's 2 here, 2 here, 2 here. Okay, so also 6 pi e. Okay. So this one also be aromatic bond. Okay, so right. So make sure that write down this. That's kind of important kind of if you have kind of the heter atom in the ring structure. Okay, how do you count the pi electrons? Okay, so to see kind of what's bonding to the kind of the heter atom. Okay. All right. Okay, and then in the end, okay, so we come kind of the charged species. Okay, so far the old aromatic compound we learned kind of all have the just neutral neutral kind of the species. Okay, and but for the charged species it can also be aromatic compound. Okay, so example showed here is kind of the cyclopentanediene kind of R9. Okay, so this species kind of the has the 5 carbons. Okay, and the in ring system. Okay, so and then there's kind of the carbon. Okay, carbon has kind of one lone pair electrons on it. Okay, and keep in mind, okay, we learned kind of the chapter 3 or maybe 2. Okay, hybridization assignment. Okay, so so when we count kind of the sp2 or sp or sp3. Okay, so we look at kind of lone pair electrons. Okay, kind of adjacent pi bond node. Okay, so although they're kind of totally the 4 electron densities. Okay, 4 electron. 3 single bond, 1 lone pair electron. But this lone pair electron adjacent kind of pi bond, we need -1. Okay, so 4 minus 1 gets 3. Okay, so that's why this carbon kind of sp2 hybridized. Okay, right. And then for this lone pair electron, actually kind of in the orbitals. Okay, p orbitals, okay, p orbital, okay. So that's why kind of aromatic compound, okay. So yeah, the 4 electrons from kind of theta bond, and then lone pair electron from this here the charged carbons, okay. Also kind of part of the pi systems, okay. So that's why kind of totally 6 pi electrons, okay. And that's should be kind of aromatic compound, okay. So that's something keep in mind, okay. So the charged species can also be aromatic compound, okay. So whether you need count kind of the lone pair electrons on the pi system, okay. So you still apply kind of a rule which is learned before, okay. So whether this charge species connected by kind of the single bond or double bond, okay. So this one already connected by only single bond, okay. So that's the lone pair electron belongs kind of this pi bond system. You need to count these lone pair electrons, okay. So that's something you can keep in mind, okay. Right. Another example is kind of with this time comes kind of cation, okay. So called kind of tripotylene, tripolium, okay, tripolium kind of cation, okay. So this time kind of has kind of 6 membrane, okay, 7 membrane, okay. So sorry, 7 membrane, okay. And then the carbon has kind of the 3 bond, and then there kind of empty p orbitals, okay. So still sp2 hybridized, okay. And then when you count pi electrons, okay, don't count anything on kind of this the positive charge carbons, okay. But you still can keep in mind, okay. So although this the positive charge carbon don't contribute any kind of the pi electron, but contribute to kind of the conjugate system, okay. So empty p orbitals, contribute kind of empty p orbital, okay. So this one involve kind of the conjugations of this species, okay. So that's makes the whole thing kind of the cyclic planar also kind of fully conjugated, so not break up conjugation system here, okay. So that's why kind of the aromatic compound, okay. So count pi electrons, still 6 pi electrons, okay. So nothing in kind of this empty p orbital, but the whole thing kind of aromatic, okay. So that's the very kind of interesting thing kind of the for this cation, 3 pi electrons, no other kind of bonded pi electrons, okay. It contains 6 pi, kind of follow kind of the Hooker rules, okay. Right, and here's kind of more examples, okay. And so for that's called kind of cyclo propenyl kind of the carbocation, okay. And this one has kind of only 2 pi electrons, okay. So because only kind of one double bond, okay. And so there's kind of the third kind of the carbon, okay, contribute only empty p orbitals, okay, won't contribute any pi electrons, but involve the whole kind of conjugations, okay. So that's why kind of follow kind of the Hooker rules, okay. So fully conjugated string structures and those kind of plan structure, okay. And then only 2 pi is kind of the n equals kind of 0, okay. So 4 times 0 plus 2, okay, give kind of 2 pi is. That's why this molecule kind of the aromatic compound, okay. And then another example kind of the anti-aromatic compound, okay. So this one kind of the cyclo propenyl kind of anion, okay. So this one has kind of the 2 pi electrons, okay. So in the this empty kind of this kind of the negative charge kind of carbons, okay, and then 2 pi electron in one kind of conjugation with another 2 pi electron in the double bond, okay. So 4 pi is, okay, 4 pi is, okay. So overall should be kind of the anti-aromatic compound, okay. So and another anti-aromatic compound is kind of cyclo pentadiene kind of the cation, okay. So this one has kind of the no charge, okay, no pi electron in this empty p orbitals, okay. But the involve conjugations, okay. So then you count kind of pi electrons, only 2 pi bond, okay, and then 4 pi electrons, okay. So 4 rules, okay. So anti-aromatic compound, okay. And so that's why explain kind of the why this cyclopentadiene kind of has a very strong kind of acidity, okay. So reason for that kind of acidity kind of how easy you release kind of protons, okay. And then because once you release protons, you generate kind of cyclo pentadiene kind of the anion, okay. So this particular anion kind of the aromatic compound, okay. So in case kind of remember, okay, molecule like to be aromatic compound, okay. So because it has lower energy, okay. So that's why can this species kind of the more stable compared with kind of original kind of species, okay. And then that's why the whole process kind of easy to go to the right, okay. And generate kind of a lot of protons, okay, and then that has kind of pretty high kind of PK 15, okay. And remember, okay, so yeah, for this kind of allelic kind of proton, okay, so that's allelic proton, okay, so yeah, normally speaking, kind of the PK around kind of 44, okay, so yeah, pretty kind of weak acidity, okay, but here the for this here the cyclo butadiene kind of the species, okay, so yeah, anion, okay, PK kind of 15, okay, because kind of won't be kind of aromatic compound, okay, right. And just the little bit the things you guys can record, okay, so not necessary, but 90% type kind of right, okay. So if there's kind of cation, okay, right. So don't count any 0 pi electrons, just kind of count 0 pi electrons, okay, cation, okay. And if it's kind of anion, okay, normally speaking, you need count 2 pi electrons, okay. So add 2 pi normally from kind of lone pair electron on the anion, okay. And so there are kind of one additional kind of radical, okay. So radical, but a little bit out of the class, okay. So you only count 1 pi electrons, okay. Only 1 pi electrons, okay. So that's when you how to count kind of pi electron, whether for kind of 4 plus pi rule, okay, or kind of for kind of the 4 kind of the rules, okay. So aromatic or anti-aromatic, okay. So that's you can use this rule, okay. 90% times kind of right, okay, but occasional kind of there's some situation not right, okay. So all right, okay, so I guess that's done the class today, okay. So do you guys have any questions? Yeah, if you have any questions, can you type in kind of the chart window, okay.
No questions. Thank you, Dr. Liu.
Yeah, thank you. Yeah. All right, so if there's no further questions, okay, so I'm going kind of stop kind of the class today, okay. And we have kind of a discussion tomorrow, okay. So also kind of office hour tomorrow, okay. So if you have a question, okay, you can ask it then, okay.
Hey Leo, I have a quick question for you.
Yeah.
For some reason on my Educat page, whenever I click on the recordings, like the recording is not there for like yesterday's lecture. I was wondering if I could like get the link for that through email or something.
Okay. Yeah, so I don't know, okay, a lot of students report this issue, okay. So first you kind of make sure that your browser don't block kind of the pump, okay, pump up window from the Educat and also OneDrive, okay. And another situation kind of I don't know, some kind of maybe you kind of the software issue, okay. So block some kind of videos, okay. And so in this case, I can share I will send you kind of email, okay, about kind of the video link, okay.
All right,
Yeah.
thanks. I'll try to check to see if like that the pop-up thing is like the reason why, but
Yeah.
yeah,
And,
if not, like if you could send me the link, that'd be great.
yeah, when you click on the link, do you see kind of just totally the white blank, or kind of you see kind of grill window?
It's just blank and it just says
Oh,
like the
blank. Okay.
title.
Oh, so if that's just blank, okay, wait like maybe 1 minute, okay. So because that's kind of huge the file, okay. So when you click on it, okay, so take like maybe half a minute to load it, okay. So a little bit patient, okay. So and then wait like maybe where, okay, and then the window will kind of show up, okay. Yeah.
All right, I'll check back on that.
Yeah.
I'll let you know if it doesn't work.
Yeah, all right, thank you. Yeah, if you kind of show kind of green window, okay, show kind of the broken link, or kind of the kind of show the link, okay. So that's probably kind of the pop-up problem, okay. So if the kind of just totally white window, nothing show up, okay. So that's normally means kind of the just the loading the file now, okay.
All right, thank you.
Yeah, thank you. Can you move them on Monday? Okay. So if you have kind of conflict schedule, okay, so some students have to work at kind of evening or kind of some other if you on kind of the Friday, okay, so send me email, okay, so I can give you kind of make up exam, okay, at another time, okay. Yeah, just send me email, okay.